You've seen them, right? Marching in those perfect little lines, carrying some crumb that's way too big for them. But what if I told you that the common ant is hiding some of the most sophisticated secrets in the entire natural world? Today, we're digging into the incredible, hidden genius of these tiny engineers.
So let me just start by asking you a question. What could possibly connect supercomputers, bleeding-edge robotics, and life-saving medicines? It sounds like a bit of a riddle, but the answer, it's probably hiding in plain sight, maybe even in your own backyard.
Yep, the answer is the ant. I know, it's an insect so common, so seemingly simple, that most of us just walk right past them without a second thought. But this tiny creature has mastered principles that our best human scientists are only now starting to fully grasp.
To really get this, we have to completely change how we see an ant. Stop thinking of it as one little bug. The real magic, the real genius, happens when you look at the entire colony. Because it doesn't act like a group of individuals. It acts like a single, unified being.
This idea is called a superorganism, and here's a way to think about it that really makes it click. Individual ants are like the cells in your body. Each one has a specialized job, right? But they're so completely wired for teamwork that a single ant literally can't survive on its own for long. The colony itself is the real creature, a massive, sprawling intelligence with no single point of control.
And let me tell you, this strategy, it works. Scientists estimate there are around 20 quadrillion ants on Earth. That's a 20 followed by 15 zeros. If you could somehow weigh all of them, their total mass would be more than all the wild birds and mammals on the planet, combined. They've conquered pretty much every corner of the globe.
Which, of course, brings up a huge question. How do millions, sometimes billions of individuals coordinate everything so perfectly? I mean, there's no CEO in the anthill, no general shouting orders. So how in the world do they pull it off?
The answer is both beautiful and simple. Pheromones. These are chemical signals they leave for each other. It's a form of indirect communication that scientists call stigmergy, where one ant's action leaves a mark on the world that tells the next ant what to do. You can almost think of these pheromone trails as the software that runs the entire colony, a set of invisible instructions that guides the group without anyone ever giving a direct order.
And this system lets them solve incredibly complex problems. Let's just walk through a classic experiment to see exactly how. So first, you've got foraging ants. They find a food source and they create a straight path back to their nest, laying down that chemical trail as they go.
Now let's mess with them a bit. We drop an obstacle right in the middle of their path. It's blocked. The ants that get there have to make a choice, and since they have no idea which way is better, they just split up. Some go left, some go right, exploring both the long way and the short way around.
Okay, and this is where the real genius kicks in. The ants that just happen to pick the shorter path obviously get to the food and back to the nest faster. Because they're completing that loop more quickly, they're reinforcing their trail with fresh pheromones way more often than the ants taking the scenic route.
It's an amazing positive feedback loop. The shorter path gets smellier and smellier, its pheromone signal getting stronger and stronger. In no time, basically all the new ants are drawn to that powerful signal, and a new, super efficient highway is established. They solved a complex logistics problem with zero management.
This is a perfect example of what's called emergent behavior, where you get this incredibly complex intelligence from a few very simple rules. And it's so powerful that there's a whole field in computer science named after it: ant colony optimization. We use it to solve our own tricky problems, like routing delivery trucks or managing telecommunications networks.
So how do we actually take this natural algorithm and use it in our tech? Well, it's a perfect example of something called biomimicry, where engineers look at nature's time-tested designs and adapt them to solve our own challenges.
This whole idea is so intuitive that it's even popped up in video games. There's this great quote from a review of the game Empires of the Undergrowth that just nails it. It says you don't command your army by clicking on units. You command them by painting pheromone trails, telling them where to go and what to do. You're literally using the ant's own logic.
But it goes so far beyond games. Check out the desert ant. This little creature is a navigation master. It can find its way home across a barren, featureless landscape. On the left here, you can see its toolkit. It uses polarized light from the sun as a compass. It actually counts its own steps to measure distance, and it gauges its speed by watching how fast the ground moves beneath it. Now look on the right at Antbot,
a robot built by French engineers. It's a direct copy. It's got UV sensors to act as a solar compass, a memory chip to count its steps, and an optical camera pointing down to measure speed. They just copied the ants' homework.
And believe me, this isn't just a fun little experiment. A robot that can navigate without GPS? That is a huge deal. Think about search and rescue bots going into collapsed buildings where there's no signal. Or rovers exploring other planets. All of it guided by the ancient wisdom of the desert ant.
So we've got decentralized computing. We have advanced robotics. All from ants. But their genius goes even deeper than that. The story gets even more incredible when we zoom in on one specific group, the fungus-growing ants.
What if that superorganism we talked about isn't just the ants? What if it's actually an ancient, four-way partnership that figured out sustainable agriculture and custom medicine millions and millions of years before humans even existed? Now look closely at this ant. That chalky white stuff on its body? That's not a sickness or some kind of mold. That is a living coat of bacteria. And these bacteria are the ant's own personal pharmacists, producing powerful, custom-made antibiotics.
Here's how this whole amazing system works. Around 60 million years ago, these ants started farming a special kind of fungus for food. But their gardens are always being attacked by a nasty parasite, a different kind of fungus. The ants' defense? They started cultivating these friendly bacteria on their own bodies, which produce antibiotics that are perfectly tailored to kill the parasite without harming their food crop. It's a non-stop arms race, and the ants are fighting it with living medicine.
So what you end up with is this absolutely stunning four-part symbiotic relationship. The ants feed the fungus feeds the ants, the bacteria protect the fungus, and the ants give the bacteria a safe place to live. It is a perfect, co-evolved system of survival.
So, after all of that, after diving this deep into the anthill, what are the big takeaways? Why should we really care about the hidden genius of these tiny creatures?
First, it shows us that you can get mind-blowing complexity from a few really simple rules, creating a decentralized system that's incredibly tough and adaptable. Second, it's a powerful reminder that nature is just this huge library of brilliant, time-tested solutions. The answers to some of our biggest engineering challenges might literally be scurrying under our feet. And finally, it shows that collaboration, even between totally different species, is one of the most powerful strategies for not just surviving, but thriving.
When you think about it, ants mastered decentralized algorithms, GPS-free navigation, and precision agriculture millions of years before we even had words for those things. It really just leaves you with one final fascinating question. What other revolutionary secrets are out there, hiding in plain sight, just waiting for us to finally pay attention?